All right, welcome to statistics. I've been on this. So today we are going to talk about chapter 6 here. Actually, let me go ahead and share my screen. Okay, we're going to talk about chapter 6 and just kind of walk through it. Okay, so I'll say a couple of things as we're going through this, so this will work out. But we're talking about distributions today. Okay. We're talking about distributions. Now, the thing about a distribution is pretty much like, here's the possible values. Okay, so we're going to get the outcomes. And that's going to be on one section of a table, and it can go vertically or horizontally, it doesn't really matter. And then the probability associated with each of those outcomes. Okay, so the outcomes don't have to be numbers, all right? A lot of times they are, because we talk about dice, but we could talk about lots of different things for this, okay? You could talk about, like, what's the probability that it's red, green, or yellow for a light that you get to, okay? Or we could talk about surveying a bunch of people and talking about where they want to go on vacation, okay? If you're into CDC stuff, you want to do mortality things, we could talk about cause of death and the probability that each of those causes of death. So they don't have to be numbers, but they like I said, they often are. So when we talk about this, okay, so they're just going to give us a problem here, and they're going to say what's going on. So you have to remember the three things about probabilities, though, right? The three rules: that your probabilities must be greater than 0, okay, or greater than or equal to, okay. They have to be less than or equal to 1, okay, and all of the probabilities add up to 1, okay. So everybody has to add up to 1, and they have to be between 0 and 1. Okay, be careful about that, because there's a couple of questions I have that ask you, do they add up to 1? And people are like, yeah, they add up to 1. I'm like, yeah, but they also have to be positive. All right, so be careful. All right, so let's just dig in and start looking at a problem here. Okay, so probability. Let's see here. The number of extracurricular activities a college freshman participates in. All right, so we have a thing here. We could check, we probably should check to make sure this is a probability distribution. Okay, so we're going to add these up. So we're going to say 4 cents and 13 cents, 47 cents, 23 cents, and 13 cents again. Okay, so I'm going to grab my handy dandy calculator here. All right, and we're going to say 4 plus 13 plus 47. These are all in cents, so I know these are each going to be decimals. Okay, but we end up with 100 pennies. That's $1, so that's equal to 1. Okay, if I put in all the little decimal places here. Okay, so there we go. They add up to 1. Fantastic. It's probability distribution. All right. That wasn't even a question they asked. Okay, so let's see. What are they asking? What's the probability that a student participates in exactly 3 activities? All right, so we just look at the 3 here. We say, okay, well, that's 0.23. Okay, so 0.23. You don't need the leading 0. Okay, I like to be, I try to be good about writing those in, since a lot of students are for medical professions, and they really like the leading 0. So we try to add it. Probability that students participates in less than 3 activities. So the first thing you have to ask yourself is, like, is 3 less than 3? Say yes, 3 is definitely less than 3. Okay, if you tell your child you can have you can have less than 3 vegetables for dinner tonight. Okay, they'll be overjoyed. So they can't have 3 if they have less than 3. So we're going to count up 0, 1, and 2. Those are the numbers that were less than 3. Okay, so for 0, for 1, and for 2, we can look up those probabilities. Okay, so that's 4 cents. Okay, so we have, this is 0.04, 0.13, and 0.47. And we're just going to add those parts up. Okay, So what are we going to do here? We're going to say we have 4 plus 13 plus 47 equals, and again, these are pennies. Okay, so we're talking about the pennies here. So we have $0.64, right? So we have 64 pennies, or we have $0.64. Okay, so we want the dollars. We want 0.64. All right, so the probability of the thing we want here, we want 0.64. We just add those up. All right. And then probability that a student's produced in at most 3 activities. So now 3 would be included. Okay. So why are they doing this to me? Like, well, later on, this is one of the big things that students get, they have a tough time with, is less than 3, no more than 3. Okay, exactly. This is a part of the problem that actually is kind of a difficult thing for a lot of students. Okay, so I didn't put the leading 0 in. Said, look, it's not customary, but they let me have it anyway. Okay, let's go with this. So the way you want to use this video, by the way, is you would actually rather can I resize this thing? You would like to do the problem first. So you want to pause it right here, see if you get the right answer, and then check to see if we're doing it right. Okay, so determine whether or not the random variable described is a discrete or continuous. The number of dental visits a randomly chosen person had in 5 years. Well, unless you get some weird definition, you're not going to have half a dental unit, okay, or a dental visit. So we're going to say discrete. Okay, you're certainly not going to have pi dental visits. All right, so we're just going to go ahead and say that discrete. That's really all they wanted. All right. Okay, compute the mean and standard deviation of the random variable given the discrete distribution. Okay, this one is going to be a little bit more involved. All right. So first things first, expected value. Okay, expected value is simply the sum. All right, so we're going to add up. We'll just say the sum. Really? Okay, the sum of the value of the event times the probability of that event. Okay, that's what expected value is. It's the value of the event times the probability of the event. All right, and we abbreviate it as E with an X on it, and the formula is the sum X times P of X. All right. Now I'm going to show you a formula that's not in your book for the next ones. Okay. By the way, this is the mean. Okay, so mu is equal to the expected value. All right. I thought it was really powerful as a little kid because I figured this out. Okay. And none of my friends did. So I had forbidden knowledge. We'd play games, they'd accuse me of cheating. But there we go. We'd also have, so the expected value is equal to the sum of X times P of X, all right? So expected value of X squared, okay, we use this a little bit later. This is related to, it's not the standard deviation, but it's related to standard deviation, okay? And this is the sum of X squared times P of X, okay? So the value of the event squared times that probability of the event, okay? Later on, okay, if you go into higher level statistics classes, you're going to be measuring something called skew. We do not do this in this class, but this is E of X cubed, and this is the sum X cubed times P of X. I'm guessing that you're sensing some sort of a pattern here, okay? And this is not, it's not skew, it's just related to it. Okay, you're going to need this in order to generate skew, but it's not the skew. And then the last thing is related to something called kurtosis, okay? And that's E of X fourth And I'll bet you could write down the formula faster than I can. Okay. Kurtosis is kind of related to standard deviation. It's like how fast this distribution like falls. So if it falls really gentle, that's one kind of kurtosis. That's a low kurtosis. If it falls very quickly, that's a higher kurtosis. Okay. I've only had one student who ever came back and said, "No, my economics teacher asked about this, and I was the only one that knew." So chances are nobody will ever need this. Okay, but this is a really easy and nice way to kind of explain what's going on, isn't it? So I don't have to memorize a lot of formulas here. I know what this means, and now I can generate anything I want. So the formula for standard, well, the formula for variance, okay, for sigma squared is equal to E of x squared minus E of x squared, all right? And then sigma would be the square root of this thing. Okay, now your book uses a slightly different formula. Okay, and it's okay if you like the formula the book has in it because you don't have to look it up or it's real easy to find, then you go right ahead and look that up or go right ahead and use it. On a quiz, I will not be asking you for the standard deviation. Okay, there's a lot of calculations that go in here. It is very easy to mess one small part of it up and then not get the right answer. So I apologize that your book does this to us. Okay, but I can't divorce like problem 3 part C from the rest of the problem. Okay, so we're just kind of stuck with it. But I will not be asking you this question on an exam. So if you have to look this formula up, okay, sigma equals E of x squared minus E of x squared, okay, then that's fine. Okay, so this is not a formula you should be memorizing. You could always look it up. I will not be asking you this problem on an exam, okay, or on a quiz. So there we have. On a weekly check, they might ask you, but that's again, those are generated off of the book, not from me. Okay. So expected value, you got to memorize this one. Okay. This is just the value of the event times the probability of the event. Okay. But the standard deviation here, like, no, we're not memorizing that. Okay. You look it up when you need it. All right. And again, I've got a slightly different form. This is not presented in your book, but I always found it to be a much easier way to calculate these standard deviations rather than going through what the book wants us to go through. All right. So here is our distribution. Okay. I'm going to assume it's a distribution. We could check, but we probably should, just to make sure that we're all honest here. 14 plus 25 plus 23 plus 24 plus 14 equals, okay, great, 100. So let me show you how I do this. All right, we write down our x. We write down, actually, let's do it this way. No, we'll do it this. Okay, we'll keep this way. D of x. Okay, this is the stuff that we're given. Okay, so we have x is equal to what? We have -5, -4, 5, 9, and 10. You're going to need a table that has like a lot of room like this, okay? And then we're going to write down the probabilities next to it. So this was 0.14, 0.25, 0.23, 0.24, 0.14, and that was good. All right. So the next thing we're going to do here, all right, is we'll go to I'll take round. Okay. So the next column we're going to have here is x times p of x. Okay, there isn't like you must do the columns in this order. So if you want to do like x squared right now, you go right ahead and do it. Okay. So what we're going to do is take these first two columns and multiply them together. Okay. So 5 times 14, that is negative 0.70. Okay. 4 quarters, negative 100. Okay. 5 times 23 cents. I don't know. $1.15. 9 times 24 cents be 224. I know 9 quarters is $2.25, but we don't have 24-cent pieces. So this was 2.16, and then 10 times 14 cents, right? That's $1.40. Just move the decimal place over. And now we're going to add these up. Okay, we're just going to add this up. So we have negative 0.7 plus negative 1 plus 1.15 plus 2.16 plus 1.40 equals. We added those up, 3.01. Okay. So find the mean. This was 3.01. Okay. Find the standard deviation. It is criminal that they don't put a little check mark in here so you could stop, check to make sure that that's correct, and then move on with your life. Okay. And we get to the next one. So, how are we going to do standard deviation? First thing we're going to do is we're going to calculate what's x squared. So we're going to take negative 5 times negative 5. We're going to get positive 25. So if you do this, negative 5 squared, you know as a human that you're going to get a positive number. They gave us a negative number. What went wrong? Well, the calculator thinks you meant this. Okay, it applied the exponent, and then at the end it applied multiplication, just like standard order of operations. You meant this. Then you'll get the 25. Okay, but 4 times 4, 16. 5 times 5, back to 25 again. 9 times 9, 81. 10 times 10, 100. All right. Now, you don't have to rewrite the p of x in here if you don't want to. Okay, 0.14, 0.25. What was this? 0.23, 0.24, 0.14. But I've noticed that when I do this, sometimes I'm not looking at the right one. So if I have to do a weird, here we have to do 2 different columns and I'm not sure which ones they are. Sometimes I'll get a little confused. Okay, so we want x squared times p of x. This is our e of x squared. This is x squared times p of x. All right, so 25 times 0.14. I don't know. 3.50. Great. Okay. 16 times 0.25 times 0.25 is $4, right? 16 quarters, you're going to have $4. Okay, 25 times 0.23 equals, oops, clear, 25 times 0.23. 5.75. Okay, 81 times 0.24. $19.44. All right, and 100 times 0.14. This should be 14. Actually, get out of here with that. Oops. No 2 zeros. That was a mistake. It's just 14. All right, and we're just going to add those up. Okay, so that's the next thing to do, is to add those up, right? Because that's what the expected value says, is we need the sum. Okay, so what's that going to look like? Well, that's going to look like 14 plus, sorry, it's really busy over there, 19.44 plus 5.75, oops, just 1 5, plus 4 plus 350. Okay, I'm trying to make sure I got the numbers right just by looking at them. 14, 1944, 575, $4, and 350 equals. Okay, 46.69. Great. This was 46.69. So what we're going to do is we're going to apply this formula. This is e of x squared minus e of x squared. Okay, and that's going to be my variance. So we need 46.69 minus 3.01 squared. All right, let's check that out. So this is 46.69 minus 3.01 squared equals, so the variance 37.6299. I'm just trying to keep all of my intermediate calculations so that when I'm done and I want to round, I can do this appropriately. All right. So now we're going to take our square root. So second function, square root, second function, answer. So that way I don't have to type it in again. Okay, but it's just the previous answer I have, this guy right here, equals, and we end up with 6.1343. 1343. 1343. Okay, I do that right. 1343. 343. What were the instructions? Okay, the instructions said we're going to do it to 3 decimal places. So this is going to be beautiful. 6.134. 6.134. And that should be your standard deviation. Ta-da. And there you have it. Okay. So I'm gonna stop the video after this one so we can do another one. But don't be too upset with yourself on this one. There's a lot of calculations to go on here, and yeah, that's a lot. So actually, there's one thing we can do if you start getting frustrated with it. Okay, you can go to stat. You can go to clear my list. So let's go to clear list 1, clear list 2, enter. Okay, so let's go ahead and hit stat. I think this is going to work out well. So we want edit. So we want a -5, enter, -4, enter, 5, 9, and 10. Okay, on the other side here, we're going to say 0.14, 0.25, 0.23. I don't know if this works for every one of these kinds of calculators. Okay, it should work for an 84, but I hope it works for an 83. Stat, calc, one variable stats, list 1, weighted by list 2. Okay. Oh, that's not going to like that. Second function, list 1, comma, list 2. And then once you look at that, we got the right mean, we got the right standard deviation, we're all set. All right. We don't do S because we're looking for this is all population stuff. Okay, so every time you have population, it's going if it's a distribution, it's considered to be a population. Okay, that's why S does not have a value, but standard deviation does, population does. We got exactly the same thing. Okay, so it's great if you can do it by hand, but at the same time, like I'm never going to ask you, so it's okay. You can type it in a calculator, do it that way. All right, so we'll go on and do some of the other ones in just a moment, and we'll pause there. Okay, so.